on Jeff Jarrett's farm. We planted some cover crop here in the first week in August. Mixture of berseem and crimson clover, annual rye, and some brassicas, tillage radish, and purple top turnip. It was oat crop this year, so you see the volunteer oats. But we just took a spade out of a hole here about 18 inches deep, and the real benefit to the cover crop is having these roots growing in the soil longer in the growing season than what our normal crop rotation corn soybeans is. So if we could add a couple months in the fall, September, October, this particular year we're getting a lot of nice weather here in November, and then some spring regrowth of roots. What the roots do is they get down into the soil, and they're all the way down here at 18. In the pit we've got them down to 30, and they break up the soil. They make root channels, they recycle nutrients, they make stable aggregate structure, they take care of some pest issues, and basically they exude sugars from the carbon with photosynthesis around the roots, and those sugars are what is the food source for the microbial activity in the soil. And that's important for a lot of things, because the microbes basically do all the work to make the soil healthy and function. They recycle nutrients, they make nutrients available for next year's crop. So the idea with the cover crop, get some more roots in the soil, break up that corn soybean rotation, add some diversity. We got live roots for an extra few months out of the 12-month season, and that's going to really benefit our crops over time. We're adding organic matter, and we're just doing a lot of good by having these roots growing throughout the year.
We chose to start at the fence line where we don't think any tillage or other agricultural practices that may have caused erosion have really occurred. So we think this is a good location for the thickness of the soil as what may have occurred before settlement. So it's approximately here. You can see some other marks like right around here that looks to me like a animal burrow, but generally speaking it's about that thickness, which is approximately 16 inches. During the course of erosion, the top erodes away and you progressively mix the subsurface horizons into the surface. So as you're going down, the thickness, what you see at the surface, may be approximately the same boundary as you'll probably see at the other end of this pit. So as you're going down, the thickness will actually not really change that much depending upon the soils. At this site with these soils, one measurement can be done is through the use of acid, one normal hydrochloric, which with free calcium carbonate in the soil will fizz. With these soils which have developed under prairie and forested vegetation, there are organic acids released from the plants and the roots that go down and leach the calcium carbonate further down into the soil profile. And for example, at this site, we should be able to measure that. So nothing. So for this site, it's approximately at a depth of 4 feet 4 inches to where the free calcium carbonates are. There are other things you can do depending upon the soils to measure how much erosion has occurred, but for this soil, this is a good measurement. And you shouldn't expect too much change within a matter of a few feet. So this spot is approximately 13 feet downslope. Not a big long distance in the whole scheme of things, but one thing you would notice at first is that the fairly gradual color change you saw up above has become quite distinct and sharp, which you can also notice with the structure here, which it comes out as much more like bricks and much bigger pieces and much harder. So we'd put this at that depth, and actually when these dry out, they, if you have a pit face, sometimes they tend to look like a big line of bricks. So this, we have the surface thickness we would call at approximately 8 inches, which is pretty close to a normal tillage depth for primary tillage. So as you can see, it goes directly into this lighter color underneath this, actually a lighter colored surface to begin with. And then as you move down, we're going to look for our marker. And for this soil, it is calcium carbonate. So we are in a crop, this is the crop field. It's been in row crop the late 1800s. There may have been other systems of hay or things like that, but it is approximately settled then. So we're going to look for our marker here, which is the free lime in the soil. So we'll start right here and look for any fizzing, or hear any fizzing. So as we go down, you see a little bit right there, and we put more on, and you're starting to see it coming from the entire surface right there. So we will measure this point. And then we have 2 feet 8 inches, which means we have lost approximately 1 foot 8 inches in topsoil, judging from this one marker. So in this area, where would all of this soil go? Because losing 1.5 feet of soil, it needs to go somewhere. In this type of landscape, it typically does not travel very far, and it typically stays within the same field. So as you can see down below where the other pit is, which is actually full of water at the moment, so I went and took a soil core. So we can use other techniques to estimate how much soil may have been deposited in the field here. We took a soil core next to the soil pit, which is approximately 125 feet down slope. Judging from this, you can see that typically the soil eroding coming down, it is lower in organic carbon and in a lighter brown color, like you could see from the pit faces before. So you can actually see pretty well here, there is a pretty distinct line approximately right here that shows a lighter surface on the top above a darker surface. And if you can actually pan in and see it closely, you can actually see there is better soil structure and better aggregation below that surface. So at that spot on the landscape, it has gained approximately 9 inches of sediment from upslope.
We've got crimson and berseem clover, and you could see from the photos here the root mass. This was planted in early August, and it was planted into some oats that were cut and harvested. And so by adding the clover, we've got some diversity here, and the clover roots are obviously different than oat roots. So granted, we get some oat regrowth, but by putting clover in, we've added some legume to the field here. And you could see the nodules, those white little bumps on the roots. That's basically where the plant will fix nitrogen and basically put nitrogen into the soil. And so come next spring, if we were doing the soil nitrate test around here, which I think they're working on and trying to perfect it, but we'd hopefully see a little bump in nitrogen here just because we've got this clover growing for about 3 months during the season after a small grain harvest. When we talk about soil erosion and the loss of topsoil, and we realize some of it stays on the farm, some of it ends up in our road ditches, some of it ends up in our grassed waterways, some leaves the farm and gets down the river systems or into the lakes. but we got to analyze and try to be truthful with ourselves and figure out how much have we lost, what's the potential loss here as far as crop productivity, the soil productivity. It's a very hard thing to grasp, especially when technology has helped us increase yields, equipment improvements, variety improvements, fertility improvements. It's easy to say when we first started farming we had good yields were X number of bushels. Now we're getting X plus number of bushels, and so we discount the fact that soil erosion is hurting our crop productivity. But you have to ask yourself the question, if we had that topsoil back, what would our yields be? And think about the whole farm, averaging that whole field, and if you've got spots in that field, maybe it's 5% of the field, maybe it's 10% of the field where we've lost the type of soil that we see here in this soil pit. You know, what would we have been gaining on this farm had we have had that back? And like Dan was saying, it's we really don't recognize the loss too much because we keep mixing our fertilizers and soil amendments in that top 6, 8 inches, 10 inches. And so there's still a little bit of a color difference between that and the subsoil. But soil erosion is costing us. It's just hard to pinpoint. And I guess the soil health principles are, if we could follow those and just stop the soil erosion on every acre on our farm, we're going to be going down the road for better crop productivity, better yields, better bottom lines as we improve our soils.